welcome back to 2241. Today we're going to talk about quadric surfaces. So over here you can see your terms, formulas, and objectives as usual. We'll go to the objectives at the bottom in a minute. But first we'll just go through our terms. Cylinder, ruling, parabolic cylinders. So we have several cylinders and something. And then quadric surfaces, that's what we're talking about. Ellipsoids, elliptic hyperbolic paraboloids, and hyperboloids. So these are all different kinds of surfaces of degree 2. Right, and then over here we have our formulas. So our first formula is a general quadric equation. So this is really it's a quadratic equation, but they use the word quadric for three-dimensional things. And this is a very large equation, and we don't actually have to worry about it all that much. This is just where everything comes from. The most general equation of degree 2 in 3 variables. All right, and then so by choosing specific values of A, B, C, D, E, F, G, H, I, and J, you know, there's a lot of letters, we can get other shapes like an ellipsoid. And so an ellipsoid in general form looks like this, very similar to a circle or an ellipse, except we have one extra term there for the z variable. So we'll see a picture of an ellipsoid on the next page, but we'll keep going here. Next is the elliptic paraboloid. This is like the x squared graph, but extended to 3 dimensions, where you now have an x term and y term. And then the hyperbolic paraboloid. So this one is the saddle shape. And again, we'll see a picture of this on the next page. But the hyperbolic paraboloid is a saddle, and it has this minus like a hyperbola does. All right, next up is the double cone. This one has the z squared as opposed to the regular z for the paraboloids. But the z is on the other side, like the paraboloids and unlike the ellipsoid. Okay. And then the hyperboloids, these are one-sheeted and two-sheeted. And again, we'll see pictures of those. The one-sheeted hyperboloid looks like this. It has all of the variables on one side, and one of them has a minus. Think one sheet, one minus. The two-sheeted has, again, all of the variables on one side, and then 2 minuses. So again, 2-sheeted, 2 minuses. The objectives here are short and to the point. I want you to be able to identify what kind of quadric surface you're looking at from an equation. And medium objectives, I want you to be able to take a description of a surface and write down an equation corresponding to it. And then last, I want you to understand how sections of surfaces work. So sections, traces, rulings. Again, we'll define this on the next page. Okay, so going over here to our terms, we have lots of pictures here. First off, a cylinder. So this is the classical cylindrical shape. It's a soup can or a rolled up newspaper is a cylinder. But in mathematics, we talk about cylinders a little bit more generally. Sometimes this is called a generalized cylinder. But basically, it's all lines that are parallel and pass through a given curve. So if I take the, what would this be? The y equal x squared curve here. And then I take all of the lines that are perpendicular to it and perpendicular to the xy plane and pass through that y equal x curve, then I get the shape that is the parabolic cylinder. And that's what this is, the parabolic cylinder. All right, a ruling, or sometimes a trace or section, is the blue lines that I drew up here. They're the coordinates relative to a surface. So if you were able to write down some equations for this, you can maybe say, all right, this is the x direction along the cylinder, and this is the y direction, or this is the u direction, and this is the v direction. All right, next up the parabolic cylinder. Well, I just copied that down here. We have parabolic cylinders. Specifically, this is when the plane curve is a parabola. You could also have curves that look sort of weird like this, and then have a cylinder that kind of looks like this. And this counts as a cylinder, again, just because it's all of the lines that are parallel to the are parallel to each other and perpendicular to the plane containing this curve. That's a cylinder in general. Okay, up here we have the ellipsoid. It is like an ellipse that has been rotated into 3 dimensions here. So we have an x-axis, a y-axis, and a z-axis. It looks like a big football sort of shape, or an egg maybe. The elliptic paraboloid, okay, it's got a parabola-like shape, but if I look at cross sections here that are horizontal, then I might see an ellipse. So this is an elliptic paraboloid. All right, now the hyperbolic paraboloid basically takes one of these parabolas and flips it down. So here we have a paraboloid, or a hyperbolic paraboloid with one parabola in this direction, and then another parabola facing in the opposite direction that is perpendicular to the first one. And that creates our saddle shape here. All right. Last are the hyperboloids. So these are the 3-dimensional equivalents of the hyperbola in 2 dimensions. So one looks sort of like a squished cylinder. You sort of take the cylinder and you squeeze it in the middle, maybe like a corset or something. And then that's the 1-sheeted hyperboloid. The 2-sheeted hyperboloid has, well, 2 separate parts. And this is a little bit more like the hyperbola in 2 dimensions that has 2 separate parts. But you can also think of this as maybe what happens when you sort of keep squeezing this 1-sheeted hyperboloid, squeeze it tighter and tighter and tighter and tighter until right in the middle it becomes a cone. And then if you keep squeezing it, well, the only way for it to go is up and down. And so you create a 2-sheeted hyperboloid. Whereas maybe if you start squeezing these guys towards each other, they'll turn into a cone, and then you end up putting a hole through the middle and you get a 1-sheeted hyperboloid. All right, last, a quadric surface is any of the above shapes that we've just drawn. All right, so pretty short overview, not much to worry about in this section. We're just going to be learning about how to recognize these things from their equations.